severe allergic shocks, tissue necrosis, unexplained internal bleeding, all caused by a slow, soft-bodied insect that cannot run or hide. Its goal? Consume enough calories to fuel its own self-destruction, melting down into a chemical soup to rebuild itself. To survive long enough to dissolve, some species have evolved defenses so severe they routinely send even humans to the ER.
Cinnabar Moth Caterpillar.
The cinnabar advertises its toxicity with high-contrast yellow and black bands. Sweeping across the grasslands of Europe and Asia, it does not synthesize its own poison. It extracts it. Feeding entirely on toxic ragwort, it pulls liver-destroying alkaloids from the plant and stores them in its flesh. The strategy is built entirely on sacrifice. The poison is not fast-acting. When a predator swallows one, the concentrated alkaloids induce severe, violent sickness. The individual caterpillar dies, but it leaves a permanent psychological scar. The predator learns to fear the colors, ensuring the rest of the population survives the season. The adult cinnabar moth carries this toxic payload into the sky, emerging as a striking red and black flyer that is strictly avoided by the very same predators. Saddleback Caterpillar. Hidden deep in the foliage of the eastern United States, the adult saddleback slug moth is a compact, furry brown flyer perfectly adapted for total camouflage. But its larval stage abandons stealth for immediate physical punishment. Its back is flanked by fleshy ridges covered in hundreds of fragile, hollow spines. They function as biological needles. The slightest brush from a predator snaps the brittle tips, driving the jagged ends into the skin and releasing a potent dose of histamines and enzymes. The venom breaks down cellular walls, triggering intense, radiating pain in a grid of spreading welts. It is a direct, agonizing deterrent designed to force the attacker to let go instantly. But venom requires a massive metabolic effort to produce. The alternative is total visual deception.
Spider Mimic Caterpillar.
The spider mimic relies on active structural fraud. Replicating the shed exoskeleton of a dead tarantula, it tricks visual predators into processing its shape as empty debris. If a bird strikes anyway, the defense shifts. The thick, hair-covered appendages detach instantly upon contact. The bird is left holding a severed, lifeless limb, while the core organism drops freely to the forest floor to escape. This North American native carries its deception straight into adulthood, eventually morphing into the monkey slug moth, a creature that perfectly mimics a shriveled, dead leaf to hide from the very birds it fooled as a larva.
Fire Caterpillar.
The fire caterpillar uses texture as a trap. Its exterior is covered in long, soft hairs that obscure the true shape of the body. This softness conceals a dense underlayer of rigid, venom-filled spines. When a predator bites, the soft hair collapses, allowing the hidden needles to pierce the soft tissue of the mouth. The venom causes rapid, localized swelling and intense burning. The animal must commit to the bite before it realizes the prey is toxic, guaranteeing a full injection. While this venom is designed to deter small birds and mammals, one species in South America has scaled this exact chemical architecture to trigger internal bleeding in humans. We will reach the assassin caterpillar soon, but first, the surviving organisms must execute their final biological mandate. The histolysis phase. Once a caterpillar anchors itself and the outer skin hardens into a chrysalis, the biological reality of its transformation is far more violent than simple growth. The creature literally dissolves itself. It releases enzymes that flood its interior, breaking down its own musculature, its digestive tract, and the majority of its nervous system, until the animal is reduced to a sterile, nutrient-dense fluid. The organism we watched is entirely gone. But floating within that biological soup are dormant cell clusters that immediately begin to drink the liquefied remains of the old body. They use that raw, recycled protein to rapidly assemble a completely new anatomy, dismantling the venom spines and warning colors forever. Yet the biological wipe is not absolute. Microscopic fragments of the central nervous system manage to survive the chemical bath. Experiments have shown that the adult moth emerges retaining associative memories from its larval stage. It remembers the threats it learned in a body that has been utterly digested.
Puss Caterpillar.
Looking like a teardrop-shaped piece of mammalian fur, both the Puss caterpillar and its adult form, the southern flannel moth, seem like they belong in a children's book. But encountering one in the southern United States or Mexico is a medical hazard. This visual and textural deception invites direct contact, ensuring a predator presses deeply into concealed venom glands. The payload injected is chemically distinct, bypassing localized swelling to trigger systemic distress. In humans, the venom causes immediate, bone-deep pain that radiates up the limb to the lymph nodes, often inducing cold sweats and chest pressure that perfectly mimics a cardiac event. The softness is not a shield. It is the bait. Processionary Caterpillars. These species escalate the defense mechanism by removing the need for direct physical contact entirely, turning European and Mediterranean forests into hazard zones, often marked by explicit warning signs. They weaponize their setae into airborne shrapnel. Moving and feeding in synchronized head-to-tail columns, they saturate their environment with millions of microscopic hairs containing the toxic protein thaumatropiene. A sudden breeze is enough to detach them. The hairs drift through the forest, embedding into the eyes, skin, and respiratory tracts. It is an invisible, biological area denial weapon. For small forest dwellers, it is fatal. In predators that investigate the columns directly, such as canines, the localized reaction causes rapid tissue necrosis, often resulting in parts of the tongue sloughing off entirely. After this reign of environmental terror, they pupate into gray, unremarkable moths that vanish into the bark.
Assassin Caterpillar.
Concentrated in the forests of Brazil, the giant silkworm moth lives only long enough to mate. It is a fleeting, unremarkable existence, serving solely to leave behind its lethal offspring, the assassin caterpillar. And this larva does not bother with pain. It goes directly for a systemic kill. A momentary brush against its bristles injects a catastrophic enzyme into the bloodstream that completely destroys the body's ability to clot. It effectively turns blood to water. The reaction is quiet at first, but within hours, the victim begins to bleed from the gums. Blood seeps from the eyes. Old, healed wounds break open and bleed all over again. The internal hemorrhaging accelerates, unstoppable, until the rising pressure triggers a fatal brain bleed. This is no longer a deterrent. It is a biological execution. A temporary, soft-bodied larva resting silently on a tree branch, armed with the chemical capacity to drop a human being.